So, today we are going to start to the inheritance in Python. Okay? So, what is inheritance? Anyone knows that? Anyone? You can write or tell. The inheritance in Python allows us to create a new class that inherits or possesses the properties and behaviors. What's the behaviors or the properties? Which is called the attributes and methods, okay? From an existing class, okay? So the existing class is called the parent, okay? Which is called the parent or the base class. And the new class is referred to as the child, okay, or derived class, which is just like the in C or C++ programming language, especially for the C++ programming language, we can create this class properties. But in order to understand these things, we need to give the some example. For example, every car has a tire, right? Plastic. And so we can create the tire class because we know that every car, BMW, Audi, Cherry, or something like that, possess this feature, okay? Just like, for example, we can create the glass class or the DSG class or door class. We know that every car possesses these features. And so, if you want to design these classes, Audi class, BMW class, and so we can create the general or common classes. For example, the tire, for example, DSG, or the door class. And so, we can drive this BMW, or Audi, or Cherry, based on these classes, okay? Because we know that every car possess these features, okay? And so we can define one tire class and its property can be inherited to the another class, okay? This is a common general notation in here. And also basic syntax is that we can write the class and this is the derived class name, okay? And also we can open and close the parentheses in here, the base class name. And also we should put the double dot in here and we can write the class elements or the methods in here, okay? This is the basic syntax about what the inheritance. And so the inheritance is utilized to what? To expand our solution or the tire or the door class into the what? Into the another car classes, BMW, Cherry, Audi, and something like that, okay? Do you have any question about its syntax or the semantic in here? Do you understand what I'm saying about the inheritance, guys? Any question? If there's no question, in order to understand that, so we need to write the examples. We can define the class A, okay? And so therefore, self should be given in here, and therefore, the print foo should be given in here, just like this one, and def bar self, okay? and def tar can be, no, it's not this, this is the print bar. Okay, and so class B, but it's derived from the A, just like this one. This is the basic syntax. And so def tar self can be built with the what, the print tar. Okay, and so if we create the B classes in here, and so we don't have any error. This is the basic inheritance structure or the syntax. Okay, so this is the B, and so B can be called to the what, to the tar, right? See, tar is seen in here, but B dot possess another function in here, foo and tar. And where is it coming from? Is it coming from to the what? They are coming from the class A, and so this class A inherited, can be inherited to the what, to the B in here, just like this one. And so we can call the foo just like this one. See, tar and foo can be called based on the what, the B variable, which is defined in the B classes. And so B bar can also be called in here just like this one. This is the basic syntax about the what, about the how we can build the inheritance. Okay, in here, this is the basic feature. So in order to understand the properties of these terms, this is the method inherited, or the derived method can be used in here. But how about the variables? Class A can be defined with what, the set A function, self, and A can be given in here, and self A can be assigned with the A. Okay, so def disp A can also be written in here, the print self A. Okay, and after that class B derived from the what, A, and so set B can be given in here just like this one, B, and self B is equals to the B. Okay, can be assigned, and def disp B can be written as self and the print self A, and also self B possess to what, the feature of the A, right? This self A is an internal variable related to the class A, but this B possess also this self B body in here. Okay, and so after that we can write the B in here, and B set A can be assigned with the 10. Okay, and B set B can be assigned with the 20. And so if I run this code, and then there's no error because the B possesses the function of the set A, disp A, because the class A possesses this function, and B is derived from the what, A, and so set A and disp A is contained in the what, in the class of the B. See, set B and set A can be assigned in here just like this one, and so B disp A can be called in here just like this one. See, self A is related with the what, with the class A, but we can call the B dot disp A in here, and also we can print the self dot A body related to the A class in here, and also see that B disp B can also be called in here. See, 10 and 20 is given in here, and so this B class has to what, the self A and B, right? We can reach this value. The internal value can be this given here just like this one, but if this like that, the B can be recreated in here, and B set B is 20 value, and so B disp A can be called in here just like this one. What happens if I run this code right now? What happens? Why, Mustafa? Why is error? Yes, missing parameter A is given here because if we set this function and so B disp A can be called in here, but disp A cannot be created in here. Until now the A is not created or has not been created yet in here, okay? Because the self A should be created with what? With the set A function parameters in here. But otherwise we cannot reach this value, because if the set A is not called in here, and so this is an error case. Do you understand right now the properties of these terms? Okay, so what about this one? The class A can be built with this term, and so we have the special function just like this one, self and A, right? And self A is assigned with the A, and also we can print the A constructor in here just like this one, okay? And also def disp A can be built with with the self, and so the print self A can be given in here, okay? This is the A. And so the class B is derived from the B, and def init can be given in here, and so automatically is assigned with with the another parameters in here, just like this one. And so B and the print B constructor is given in here. And also we can build the self B as the B, okay? And so def disp B can be assigned with the self, and so the print self B is assigned in here. But we need to know that if you build the init function, this is a constructor, right? We have talked about everything, this constructor function, in the previous lesson. But we should know that if we derived any class from another one, we add some parameters in here, but in this case we need to initialize it just like this one. Normally we can write it because the self B is created in here, and so we get the parameters of these terms, and so self B constructor is called by the creation of the B variable, right? And so the self B is created just like this one. But what about this one? B is equals to the what? B, for example, 10. Okay? And so if I run this code, and then the B constructor only is called in here. See that? Because this constructor is written by programmers. Okay? See? And so what about this one? Self A can be called in here, and so B disp B can be called just like this one. But if I run this code, and then B object has no attribute of the A, because dynamically is not created, okay? This is problematic conditions, okay? And so how can we solve this problem? If we write the constructor by ourselves, and so we need to give some another parameter. The super function is returned to the what? To the class of A in here. And so if we write the constructor of the B, and so we must also create or call the constructor of A, just like this one, with the parameters of the A in here, because the A is initialized in the constructor of these values, okay? And so we can add the 200 in here, and we can call this parameter just like this one. And so if I rerun this code, and then so the A constructor is firstly called because the super init is given in here, and after that the B constructor is called just like this one, and so the B is assigned in here. Did you understand that what I'm saying in here? Because this is important. If we write the constructor of the derived class B, and so we must also call the constructor of the base class or the inherited class in here. Do you have any question about that? Do you understand that? Yara or other guys? Okay, what about this one? We can call the super body in here, but we can also call the A init function body with the A parameters. No, we cannot write this one, but for example, Mustafa. Okay, I can repeat the self A can be assigned with the A in here, just like this one. So, which is the only C constructor, A constructor is calling in here, because the self A is derived or is inherits the whole properties of this one. Okay, and so if we run this code, we can assign this properly. But if we select this function just like this one, and so we can write it, there is no error in here. Okay, but if we want to call the constructor or build the class of A in here, we need to call the super function in here. Super returns to to this term, open and close parentheses in here, just like this one. This super is seen on the interpreter, the init function, but we need to also give the self and A also in here, just like this one. Okay, Mustafa, do you understand right now? The self A is inherited to the B, and so there is no error in here, just like this one. But we cannot call the init function in here. If we want to create or call the init function, we need to call these parameters, either this one or this one. But just remember that if we have the super function in here, we just only give the parameters of the A, just like this one. But if we call the A.init, because it's the A is the general name, and so we need to give also the self body in here. Okay, any question? Any question? If there's no error, and so we can continue with the example of these terms. Okay, and so what about this one? Class A, and so def init body can be built with this one, and so A is our arguments in here. Self A can be assigned with the A, and so we can print the A constructor. Okay, and also def disp A self, and self A should be printed in here. Okay, so class B and A is a derivation of this class, and so def init automatically assign these values. Okay, and so also we can give the B values in here, and then we can print the B constructor and also self B should be assigned with the B. Okay, and def disp, no, it's not the case, but I will show this property also in here. Disp def disp B self, and the print self B. Okay, so if this is the case and then We can create also the b with the 10 and 20 values. Okay, and so the b, this a can be called b, this b can be called. What happened if I run this code right now? Yes, Yara. But we have the 10 and 200 values in here. Not double 2 is called, because this A calls this one, this B also possess the what the self.b. Okay? You are missing to this part. And so we have another initialization property related to this super function. We can call this super function just like this one. We can give the parameters of the b. This is the b class. This is the general name of the class. Okay? And also we can give the self body in here. And also we can give the init a function in here. Either we can use these parameters or this one. Okay? And so if I rerun this code, same results is given here. But this is the expansion form of this one. Expansion form of super function. Okay? Normally, the interpreter sees this code, the upper code, just like this one. Okay? And so, if we have this property, and so we can specialize our super function based on these parameters. But, before doing that, we can use the B classes in here. This is the big B, right? Bigger B. And so, this is the general name of the class. And so, we can call this A just like this one. What happens if I run this code just now? What happens? This is the general name of the class, and so general name of the class, this A can be called in here. But what happens if I run this code? Yes. Because this pay missing one required positional arguments, and just remember the previous lesson, we need to give also the self body in here. And so if we want to do that, and so we need to give the b parameters in here just like this one. And so the 10 is reprinted in the terminal, right? And so what about this one? If we have this properties, and so this b can be called in here with the same idea of these terms. Okay? And so if you want to utilize the general name of the b, and so the self parameter can be assigned to instance, and it can be called like it. Okay? This is important. So x5, how we can utilize these features in real applications? For example, assume that we have the employee classes, okay? And so these employee classes kept the name of the name and address values of the what of the employees, okay? And so we can print the what, the employee constructor, to inform the programmer, okay? And also we can build or create the self name in here and self address just like this one, okay? And also def this employee self can be built with what, with the print name and surname. Surname is given with the what, with this one. Addresses which is given with this one. And format self name and self address is assigned just like this one, okay? This is the employee. But the employee can contain the what the worker, manager, executive, or the advisor, right? For a company, the employee can be built or they can be assigned with the workers, managers, executives, or the advisors. Okay, and so if this is the case, the class worker can be built with this one, and so we can derive from to the what to the employee. Okay, and so the def init can be given in here, and see that this init function for the worker self, name, and address is automatically assigned to the what to the arguments of this values. Okay, and so if this is the case, the automatically if we want to create a worker, we need to also give to the what to the name and addresses. This is the base properties of the what for the derived class or the worker class. Okay, and so this is the worker constructor. Okay, and so the super worker should be given in here just like this one, or we can call the super like this one. See, but if we add another parameters in here, for example the shift, self shift should be given in here. Okay, see, these are the basic parameters, but def this worker also be written in here, and so the print name, surname, and shift should be copied in here, and so also we should give the shift in here just like this one, and so the self shift should be given in here. Okay, and so if we run this code, there's no syntax error in here, but we have other problem in this case. The class manager can be built with what, with the employee of these terms. Okay, see, the manager and the worker are different classes in here because it contains the different properties, but we have also common properties coming from the employee. For example, that every person has a name, has an address, has a surname, right? And so the employee defines these common properties in here, and so this manager should be built with what, with the self, name, and addresses in here, just like this one. Okay, and so the manager, for example, contains the department, not the shift one. See, worker must be defined with the shift parameters, but the managers should be defined with the department property, not the shift one in here. Okay, if this is the case, we can write just the print worker, and this is the print manager constructor. Okay, and so we should give also self department should be assigned with the department. Okay, and def this manager self should be given in here just like this one. We can copy of all of these terms in here, but the shift should be changed with the what, the department. Okay, and so this is the department, and also we can run this code and then see there's no syntax error. But just remember the previous example, super B is given in here just like this one, and so we have two derived classes in here, worker and the manager, guys. Okay, but we have only one employee classes, and so in order to increase the readability of this code and in order to specify the base class and the derived class, we should write to this super function with the what, worker self init name and address. See, this is the same as with the previous one, but if we have the one base class and more derived class in here, we should give also these properties in here, because the worker possesses the shift body but the manager does not, but then a manager has the department properties in here but not the shift one, And so we need to give this manager in here with the self. This is important, okay? Because if you write these terms, and so this super is what built with the what with these properties of these terms, okay? Because just see that class executive derived from the manager right now. See, not the employee one, because we know that the executive is selected by within the manager peoples. Okay, see, this is the base class. The worker is derived from the what? The employee. Manager is derived from the employee, but the executive right now is the derived from the manager. See, and so def init should be assigned in here, and so we have the name and address. This is coming from the what? The employee class, but the department coming from the manager one. Okay, and also we can give the what? The region in here. See, and so the department mass and this one is assigned in here, and so the print executive constructor can be right, and so the super executive self should be given here, and self region is assigned with the region in here. Okay, and so what about this one? We can copy of these terms in here, this executive, I'm sorry, this is the manager, but this is the executive self, name, surname, address, department, and also we should give the region in here. Okay, region, this one, and so self region should be assigned in here. Okay, but in the format okay, and so if I run this code, there's no syntax error. And so what about the output of this code? E is called in here, and executive can be created in here. For example, Mehmet İşcan, and YTU, and academic, and the region is the what? Is Turkey. Okay, so what happened if I run this code? What is the output of this code right now? Can anyone tell me? Can anyone tell me? Executive is derived from the manager. Manager is derived from the employee. No, Yara. All constructor statements printed in here. Just see that we can debug this code. If we created the executive, the init function is called in here, and so this init function prints the what? The executive constructor, and also super self is called in here. This super is equals to the manager. Okay, executive constructor is called, and after that the manager constructor is called in here, and also this manager constructor printed these values, but the super manager self is called to the what? To the employee, not the worker one. And so if we run this code, and then we will have to what? Executive constructor firstly, manager constructor secondly, and also lastly the employee constructor is called in here. Now do you understand the process of the what? The executive, the manager, and the employee in here? This is the properties of the inheritance, and so we can fill everything based on these properties. Do you understand right now, Yara? Do you have any question, Yara? Okay, and so this executive can be called in here just like this one, name, surname, and blah blah blah. And so what about this one, W worker is built with what's the parameters of the worker, name, address, and shift, right? And so we need to give the Berk Baran, okay? And so the second parameter address E2 104, and so the shift is the 8 to 24, okay? And so if we didn't, the which one, Mustafa? This is the first step. So I need to write this example. See, worker constructor and employee constructor is called in here, okay, for the Berk Baran. But what about this one, Mustafa? Which one should be removed? This one or the another one? In order to build your question, you need to tell me. For example, if we remove this one, see, just now the executive is created in here, and so name, addresses, department, and the region. If we cannot call the name and addresses, and so just see that the name, address, and the department cannot be assigned in here. See, this is a problem because we cannot fill the name, addresses, and the department in here. See, executive object name has no attribute with the name. Do you understand right now? This one. This one is okay. If this is the case, and so see that the init super calls the manager in here, and so name, address, and department is also transferred to another one. There's no problematic condition. But if we write the executive and self in here, if we have the, for example, in this case we have the 3 classes or 4 classes, but you may have the 100 classes. And so you need to notify the programmer to the super of these terms in here. Yes, this is clarity. But I think we have one more property, but you don't know anything about this. We have the operator overloading mechanism, and so this super function can be called with this one. And so we can pass the another classes in here, but it's the advanced topic of the Python. Just now you need to know that it's just for clarity, Mustafa, okay? But we have another properties about the super function, but you don't need to know right now the other properties because it's the polymorphism feature. It's coming from the inheritance properties, okay? So, and maybe since we can collect these features in here in order to show the advantage of the features in here, just like this one for the Mustafa. And so, for example, if we call these properties in here, and then we can write this one. We should keep the same these properties, but in this worker, super worker self dot disp can be called in here, but we need to remove these times. This is this function, this is also this function, this is also this function, and this is also this function. We have the same name for every classes in here, okay? And so if we have these properties, and then we can write the disp self super worker self disp can be called right now, okay? Because we have this function in here, and also we have this function in here. We have the same name, but the worker possessed the two this function in here. But how we can call this function? See, it's the advantage of the super function in here. And also we can build the disp in here, the super worker, no, the manager self, okay? And also we can call the disp body in here, just like this one. And also we can call the super executive and self dot disp, okay? See, this is the advantage of the super function. If we have the functions just like this one, we have for this function, but we have, just see that we have super function also in here. And so if I run this code, see, name, surname, Mehmet İşcan address YTU, and name, surname, Mehmet İşcan address YTU, and also this one. And so what is the output of this code, or which function should be called in order to write this property right now? Just see the code. This disp possessed with the executive, and so go to this function and super executive disp. Yes, and so this super executive self disp is going to do what? To this one, because the manager possessed this function. And so super manager disp is called in here. What is the manager or the super of the manager? See, this is the employee, okay? This is the employee, but the manager is, firstly, this is called, and after that the manager continue with what? With this line. This is the 1, this is the 2, and after that this is the 3 in this case, okay? Do you understand right now the properties of these terms? Okay, any question? Okay, and so then we need to take a break, okay? And after that, at the 2 p.m. we will start.